So I started by drawing life-size 1:1 scale using a figure on the notepad, and by placing the figure on the motorcycle, it gave me an idea of how big it should be. So from there, I drew a sketch, inputting the dimensions. First thing first, size of the wheel. And then from the drawing, the wheelbase. I like to give round numbers so it's not a wacky figure. So this is in inches, right? And then the inseam, so the height when the figure sits, like the lowest part of the seat, and then a curvature. So this is the seat. So this line and this segment here, this arc, that's the seat. And then each wheel, once I drew them, I know the size and I play around, like are they going to be bigger, smaller? And then the suspension, how much travel do I give it? So, in real life, they have 11, 12 inches of suspension. You scale it down by 18 or by 20, depending on what you think your scale is. Here in this case, you say, okay, 11 millimeters, that's a lot, that's plenty. And this gives me the fairing, how high the front wheel comes in. This is where the fairing is going to be. When the suspension bottoms at this forks, everything has to be there. And then a steering head. If the steering head is too shallow, it's not strong enough. So the longer the steering head tube, the stronger it is. So here I give a distance, and we know the bar is going to be on top of it. And this visually gives me a good reference. You see that the top of the steering head is nicely above the seat, so we know the bar is going to be there. It gives us very good dirt bike proportions. Then we look at the front, the bottom tubes, where the engine cradle is. Look at the ground clearance and the clearance from the front wheel when it's fully collapsed, and also the rake, like the caster angle of the motorcycle, or how much, what do we give it. And then same with the rear. Where's the pivot of the rear suspension? Length of the swing arm, the angle, and then the arc it travels when it bottoms out. You need some room so that you can build the seat and the guard. So here I was, this is an artifact, so I was going to make the motorized version. So this was a temporary spot where I was going to put a suspension with a coil spring, yada yada, or linkage. I ended up not using this at all. So it's an artifact. Then I built the wheel. Tires, so those were measured from what the tires I had, because I didn't want to make my own tires for now. I said I'm going to use existing tires from a model. Those are truck tires. So a motorcycle tire would require the tire to be round so you can steer, right? Right now it's really awkward because it's got a sharp edge. It's a square cross section. But that's intended now to be lazy, use an existing tire, but also this way the motorcycle doesn't fall off when I'm keeping it by itself. It gives a little bit of stability for just displaying it. Of course, a real bike, you have to modify it, but that's another story. And then these are the basic bodies, the brick, base from the outline, right? So it's inspiration from the Dakar bikes from Honda's in the 80s, the NXR 750. And the sidecar is really ugly. It's nothing like the Seal Mirage. It's very pragmatic. It's just to put the figure's legs. And then I slim it down. I try to visualize the knees going around and the feet. The goal here is to create a body as big as possible so I can house the electronics, the motor, the batteries, the electronics, all the stuff I want to put inside. So I'm going to make a shape that is as bulky as possible while being realistic, while allowing the figure to sit on. Then I play with all the fillets, round things up. Round things up. Round things up. So the rear is not realistic. The rear is more like dirt bike. I didn't do the tanks and whatnot. You know, because this is still a study, so I want to be a bit lazy and move a little faster. Then here starts to look decent. Like, okay, I'm gonna have the headlights there, the instrument panel in there. Okay. Moving forward, I cut the seat. Looks good, looks realistic. Place the headlights. Okay. Steering head tube has been made. And at this stage I realized, well, the real bike I would need to make a chassis and everything, and the body has to fit on the chassis. I would have to cut holes for ventilations where the radiators are. I would have to put the engine and cut. It's a lot of work. It can be done, but since this is a study, let's make it a monocoque, meaning the body is going to be supporting all the members, all the components, and it's just a printed prototype. So here's the forks. So this is the fork holder. I've already laid down the pivot. So the pivot has to be as low as possible so that it's compliant, because if the pivot is too high, the wheel would not be able to move. So I have to lay it down and then I have to test it. So I spun the fork a few times to see the interference of the body. So this is this gap here in real life is where the radiators would be. And in our case, it's just to clear the fork so they can swivel without hitting anything. So the only way to know that it doesn't hit anything is to turn it in the software. I don't have it anymore, but let's see, I can keep going. That's more details. Little details like the fuel caps. So these forks at this stage are very conventional. If I wanted to at this stage, it'd be very easy to extend. Notice they were hollow, and that's because I was considering doing telescopic forks. I know it looks more conventional because this swing arm is a little odd with the blade, which has a flow, by the way. When the suspension collapses, it does bend the other way and rubs the wheel. So, you know, it can have a few refinements. It's many things can still be improved. Okay, and then move forward. So got the foot pegs. Let's hide the sketch so we don't see it as much. There you go. So there's no screws, no glue at this stage, except maybe for the headlight dash that needs to be glued in, because I got lazy, but you can actually make everything that's press fit, like the seat is. So for example, let me show you here. So here's what am I inside, right? So the seat is there. There's a rib that overlaps in there. And that little round bump here that hooks so the seat doesn't fall off. So I'm not an expert. I don't do complex surfaces like real professional modelers do. I mostly carve things just like if it was wood. I extrude, I cut, I shave, I add, I round things up. Here's the handlebars design, which is, the concept is to not have the figure rotating their hands because the wrists don't rotate. And even if they did, when someone's on a motorcycle, it's not just the wrist rotating, there's also some compound angles that a toy figure does not really have well. So here, the idea is to have a grip that's vertical, but the thumb is going to go past over center and the fingertips going to go past. The idea is not to have this grip inside the hand at all times, but to pinch. Here, I'm going to show you here. There you go. To pinch between the upper edge of the guard and the top of the grip, so that the thumb and the, so the thumb and the fingertips go past and then they're held there. Then the hand is resting on top, but does not need to be on it. And by the way, it would have to be the other hand and the left hand. This is for the left hand. So, I don't know where it's like, so when I make stuff, I make it and then I move it around a lot. It's not an advanced technique because people say you're supposed to know where you're going, but I don't. I'm figuring out things as I make it. So as I model it, I look at it, and it's really by eye. I'm judging and making adjustments, refine it. So here the bars are good, I mirror them. Okay. And then I got lazy. I grabbed my Warthog headlights and I brought them in. So at this stage, there's a brace. So I got lazy. This brace is minimal, it's ugly, but it's just to get the video down, to have something holding it. I didn't want to spend too much time because I don't think I'm that much of a fan of sidecars. So I said, good enough. And you notice I used the same swing arm from the rear. I had an exact copy there. So now I've got the flex leaf spring here. I need something to push against it. So I'm like, okay, let's have the anti-tank guided missile against it. So we'll make a post and we'll have that post fused against the side of the sidecar to be stiff because it's going to flex a lot. And yeah, there we have it. So now let's see if I have, there you go. So here, like rotating the bar, this is rotating them a little bit, but let's see if I rotate them all the way. There you go. So in gray you can see the bars, the full lock, to see what's the interference in the chassis. Another issue I had was the interference of the gas caps, because initially they were hitting it, so I had to resculpt the body because the bars were in a decent position, but there was some interference. And then same with the dash here, like this edge here, it was touching. So it's like, well, form follows function, right? So the form had to be adjusted so that the bars could have a full lock. And then here on the swing arm, I had to see, okay, what does it look like when it turns? Obviously it's missing a component, but I turned the entire fork to make sure there was no interference. Now this is not critical. I mean, if we play with Joes, we might not need a full lock. We might be okay with just a little bit of wiggle. And okay, so here it is. I'm going to go back. So to explain, as a kid, I never had this toy. I was never into motorcycles at the time. I wanted to acquire one now because I was looking for a new project, and my friends, all my friends who collect, told me don't get one. It's fragile. It's very hard to get with all the parts. It's not, doesn't play well. So I got nothing by criticism from people who had it. Then I look at all the vintage 80s Tamiya catalog, and I was trying to find what did they use, because a lot of detail are really, all the details of the Joe vehicles are not something they create from scratch. They kit bashed some existing toys that they had. So I think I found it. But they took a street bike. I'm not interested in street bikes. And for what the Joes do with it in the cartoon, it looks like they might need something like more off-road. So a Dakar bike makes more sense, and the very big body enables me to stuff all the electronics and everything I want to put in it. Then also, here you can see my inspiration why I had dual tanks to justify it. Then I looked at modern motorcycles, but it doesn't fit because it's, for Joe. Leaf spring. So this is something that, like I said, I can have put small springs in it, but I'm lazy. I'm going to use this flexing thing. And then the other is the leading front suspension, because I don't want to do forks because of the issues of making telescopic forks at such a small scale. So I don't have pictures of it, but the Bimota is the example of the single-sided front swing arm that's on a motorcycle. Bimota it's called. So that's what I was looking. As you can see on my drawings here, I had the same shock as the rear. There was a coil shock placed there, kind of like BMW Tilly lever. Their shocks in the head. I was going to put a shock there as well and have a swing arm. You can see the drawing here that I was doing this Bimota like front swing arm with a steering knuckle in there, so the front wheel could steer in there. And I ended up doing something closer to a ribby front fork. Here I drew what if I was making the telescopic front fork, what it would look like. And here's a sketch. I know it's weird, it's all together, right? But here's the fork, and here's the grip. So here I was drawing, so it's facing, here's the front, the grip is there, and then this is in ghost how the handguard would cover, and the hand would be over, and it would be hidden. And then here is the view of the bike with the sidecar, the gun. So I was going to put the recoilless rifle in it. And let's see if we have, oh yeah, the articulation here. I was going to put the parallel linkage here so I could lean the bike in the sidecar. So this was the intention, how to make turns. So the concept for me here as RC is to not have something fast that just goes so fast that you don't see it. It'd be nice if you can go on a table, make very precise maneuvers, climb stuff. Of course, we would drive both back wheels, and that adds complexity because there would be suspension, and then you need some CVU joints or CV joints with a prop shaft going all the way to the other wheel, because the other wheel would be suspended as well. So I did a study with what I had, and it was bulky, so I'm glad it would be a much bigger swing arm to house the gears and the bevel. So yeah, this is what you've seen from the CAD. And then I ended up just playing around with a prototype that's easy to print, requires very little gluing modifications. It's just some metal pins and you put it together and it's fun. And yeah, it's a base, it's a good study to play with. So on my files, you can see that on Thingiverse, we can, the files are there. There's there's two files, and there's the Dreadnought version, and there's the ones. But I think I did include the step files. So take the latest one by the number A4. Oh, there you go, A5, A6, there you go. I think those have been scaled down. So one thing to notice is I designed the motorcycle and then I scaled it down to make it smaller because it felt like it was too big and too tall for the Joes. So when I scaled it down, I forgot by how much I scaled it down. Oh yeah, there it is. So this is scaled here. Okay, so I'm going to go back. And I'm going to scale it. Oh, it's not verified, but I did scale it by a factor of 75%. So it would be smaller and the figure could sit on it. But when I scaled it, I only scaled the body and the seat. I did not scale the suspension. So the full-size motorcycle has a suspension, the fork that can steer all the way. When the body is scaled down at 75%, it cannot steer anymore as well. it gets stuck in between by the shroud. Now, if you use the naked dreadnought version, that one has not issue because it is cut. Where are we here? There you go, this one. The body's cut so the fork can steer. But yeah, so the dreadnought version is a scaled down 75% of the original version. So it looked good on the sketch, but eventually as you print it, you realize it's still too big. And it's funny because when you design things on CAD, things on the screen looks either too big or too small. It's difficult to have a true sense of size until you have the prototype in your hands. You know, the moment of truth when here you need to have the prototype in your hands, because from a sketch, from a CAD model, until you have it in your hands, you don't know how strong, how small, how big it is. So this is the beauty of 3D printing, is we can mock up things. Yeah, in the old days, that's what we used to do, is to mock up, take foam, cardboard, or whatnot, and mock it up to see how big it is, or what's the issue of how you handle it, because everything looks swell on paper or on the screen, but then what is it like in real life? All right, hope you enjoyed this. Thanks again.